recovery. Today, you will hear from our speaker experts, Sean Mack, Ambassador with the DevOps Institute and CIO and CISO at Wiley, and Chris Chapman, Partner Solutions Architect at AWS, covering AWS Marketplace, Service Catalog, and Control Tower. We have a lot to cover, so I don't want to delay any further, and I'm going to go ahead and pass the floor to Sean as our first speaker.
Great. Thanks so much. It's great to be here. Thanks for joining us today. I'm going to talk about a modern approach to backup and disaster recovery. So first, a quick introduction. I'm Sean Mack. I am an ambassador of the DevOps Institute and also the CIO and CISO at Wiley. The DevOps Institute is the continuous learning community dedicated to advancing the human element of DevOps success. And Wiley is a research and education company focused on enabling researchers, educators, and learners in an increasingly digital landscape. So I'll start with a brief overview, talk about some introduction to some key concepts of backup, disaster recovery, and business continuity planning. I'll also go over some key concepts of DevOps because these concepts are critical to a modern approach to disaster recovery. Then I'll get into some of the business considerations as you're designing your backup and disaster recovery strategy. And then I'll pull it together to talk about a modern approach, how you can use these DevOps principles for a modern disaster recovery strategy. Finally, I'll end with some next steps, what you can take away and apply to your business today. So let's get started. So there's a few key concepts in disaster recovery that I want to go over as a startup point. First of all, backup. Backup is simply a copy of computer data taken and stored elsewhere so that it can be used to restore the original after a data loss event. More broadly, we talk about disaster recovery, which is a set of policies, tools, and procedures to enable recovery of technology, infrastructure, and systems following an event such as a natural disaster or other cyber attacks. And then there's the even broader category of business continuity planning. Now, business continuity planning is the process a company undergoes to recover and continue operating during a disaster. So BCP will include activities such as marketing and messaging to the market when there's a major event that may impact a company in a visible way to their consumers, to the market. It also includes things like ensuring people are safe and can continue to work, as well as ensuring facilities can continue to operate. So backup is really at the core, and it's a component of your disaster recovery plan. In turn, disaster recovery is a component of the larger business continuity plan. I also want to talk about some of the key concepts of DevOps. While this is not a presentation on DevOps, we're going to look at some of the key technologies and practices of DevOps because these are critical to developing a modern disaster recovery strategy. Now, my definition of DevOps is a method for delivering value to the customer focused on collaboration and small batch sizes. Now, at its core, DevOps is really about collaboration. And it's important to note that DevOps is not just about technology. In fact, DevOps spans all elements of business, from people to process to technology. So this is just an example. This is the DevOps maturity model we use here at Wiley. And you can see it looks at all aspects of DevOps maturity, people, process, and technology. You'll also notice that some categories or some concepts here are repeated across multiple categories. For example, you'll see collaboration, but in people, when we talk about collaboration, it's referring to breaking down organizational silos, while collaboration in technology looks at collaboration tools focused on providing technology such as chat and shared code repositories that help people communicate and work together more effectively. Now, the interesting thing is, as we look across all these competencies, we find that almost all of them are relevant to a modern disaster recovery strategy. Before I get into how you apply these concepts to disaster recovery and business continuity, I want to talk a little bit about the business of business continuity planning. So I know a few things about disasters. I've seen a couple in my day. At one former company where I ran the network operations center, we were in the midst of debating the cost benefits analysis of diversifying our data centers because we only had one. At that time, a storm hit and we began to see flooding. Now, pagers went off across the company. People were scrambling to address the issue. We saw significant flooding in the lobby of our main building, and this was a problem because our data center was located in the basement directly below. Not only that, but the building was an old refurbished fishing cannery that was built on a landfill over water at the bottom of the pit of a hill. People were literally billing out the server room by hand until the pumps could arrive. Now, luckily, there was no significant and lasting damage sustained to the data center. But I'll tell you, this immediately stopped the debate over funding for a secondary data center. Now, my hope is that you don't have to go through a disaster like this in order to get funding and take your next steps on disaster recovery plan. Because the reality is that 93% of companies without disaster recovery who suffer a major disaster are out of business within a year. In addition, more than 50% of companies experienced a downtime event in the last 5 years that took longer than a full workday. Now, at Wiley, I'm CIO, but I also get to be CISO. And so I've been witness to the increasing trend of cyber attacks. You know, in 2019, Accenture reported that security breaches had increased by 11% since 2018 and 67% since 2014. And cyber attacks such as ransomware can create major disasters for the business, which we need to take the same steps to prepare for. The other concept I want to talk about, which is critical to developing your disaster recovery strategy, is the concepts of RPO and RTO. RTO is recovery time objective. This is the targeted duration of time that it will take to restore a system or services after a disaster. Recovery point objective, on the other hand, describes the targeted interval of time that data loss that's acceptable to the business. So for example, if a system takes 8 hours to bring back up in a secondary region or data center, and data is backed up every 24 hours, your RTO, recovery time objective, would be 8 hours. But your RPO could be up to 24 hours because that data that's only backed up once a day could be up to a full day old when you restore it. This is important because you need to define different RPOs and different RTOs for the different applications and services in your business landscape. Now, especially if you're a mid to large sized company, you likely have a large portfolio of diverse applications and services. This is also important to think about because there's a cost element which must be considered, because generally faster RPOs and RTOs are going to be much more expensive to maintain. So you want to look at your application landscape, look at what are your most valuable applications and services, and what are the RTOs and RPOs that are needed for those. And then look at the costs associated with the different RPOs and RTOs so you can make strategic decisions and appropriately align your architecture and your disaster recovery plans with your business needs. Now, the good news here is that by applying DevOps principles, we can help reduce costs for any RPO or RTO. So let's talk a bit more about modern approaches to disaster recovery based on some of the DevOps principles. Because these key concepts of DevOps also help drive a modern approach to disaster recovery. You know, the latest State of DevOps report showed that high-performing DevOps teams had over 2,000 times faster mean time to recovery, right? And while this applies to all types of incidents, big and small. It certainly also applies to major incidents and disasters, right? So it's clear that there is a correlation between high maturity DevOps organizations and faster resolution. Now, if we know that collaboration is at the core of DevOps, it's also key to our disaster recovery. And we need to look for ways to break down silos within our organization in order to increase and improve our MTTR. One way to break down those silos is with communication tools like Slack or Teams. By providing these tools for communication and encouraging transparency within an organization, we can drive drastically faster response times and resolution times when crisis occurs. Automation is another core component of DevOps and site reliability engineering. DevOps focuses on finding any activity that are being done repeatedly in a manual way and automating them. This automation is another key to driving rapid recovery in case of disaster. Now, there's a whole slew of tools around DevOps and a whole set of ways to do automation. In the disaster recovery space, we want to specifically focus and ensure we have tools for automated recovery, to automatically spin back up your applications, as well as automated testing tools in place. Now, I want to talk about another concept of DevOps, which also impacts disaster recovery, and that's the concept of resilience engineering. And there's a few intertwined concepts here. Resilience engineering is basically the idea of designing systems to be more tolerant of change or component failure. We also sometimes hear about high availability. Now, high availability, while similar, generally focuses on ensuring systems are highly available to individual component systems. So we may talk about this in terms of RAID arrays, where you can have a single drive fail and the array continues to operate, or even in terms of individual chip and component failures, right? And then we also talk about disaster recovery, which, as opposed to resilience engineering, which focuses on maintaining system stability, disaster recovery focuses on recovering when failure has occurred. Now, many of the concepts and methodology of DevOps helps us be more resilient and helps us to recover in case of disaster. A great example of this is continuous integration and continuous deployment, which sits at the heart of small batch and rapid deployment to get value to the customer faster in a more agile way, right? Because continuous integration and continuous deployment allows us to deploy small incremental changes constantly, many times a day, right? But these same systems, which allow us to push small incremental changes, can allow us to deploy the entire application. So in case of disaster, you can restore your application if need be using your CI/CD pipeline. Now, the other thing you need to do in this regard is to look at treating your code in the same way, using infrastructure as code. Now, infrastructure as code allows us to describe your infrastructure in a programmatic way and then treat it as code, right? So you're checking it into your code repositories. You can also then push it out and launch your infrastructure using those same continuous integration and continuous deployment pipelines. And in the same way, you can deploy from the ground up in case of disaster. Now, the last piece that we need here is configuration management, the ability to describe your application configuration. And here there are tools such as Ansible, which allow you to describe the configuration of your application, which again can be used as part of your deployment pipeline to build your application from the ground up. Now, there are a couple other concepts in resilience engineering that help us be more resilient in the cloud and also help us recover in case of disaster. One of those is elastic scaling. Elastic scaling helps us immediately scale up due to high influx of requests to meet demand of your customer. Now, this can be great in disaster recovery scenarios if you maintain a secondary regional deployment or secondary availability zone that's smaller than your primary. If the primary fails, your secondary has to take that load, and you've enabled elastic scaling. Your secondary environment can scale up to meet the jump in load that's required. And the last concept I want to talk about here in terms of resilience engineering is multi-region deployments. By being able to deploy your application and services in multiple regions, you are significantly increasing the resilience of your application, right? Because if a whole region were to fail, you will continue to operate in a secondary region. Not only that, but if you've designed your application in order to be able to run in multiple regions, it becomes increasingly easy to spin up another region from scratch should a disaster occur. And it's easier said than done. There are many requirements for multi-region deployment. You need to have data replication between regions that's fast and reliable. You need to have a global network infrastructure to connect your different regions. You should also ensure that your regional services don't have a local state. They need to be stateless, and state needs to be shared between regions so that should a region go down and a user or your user base needs to shift to another region, there is no information about the state of their transactions that is lost when a whole region is lost. But in many ways, what this means is that if you take the core practices of DevOps, you have the foundation to build a whole new approach to disaster recovery, because now you begin to build your application from the ground up in case of disaster. Now, data is always at the core, but if you get your data replication right, you can combine it with infrastructure as code, continuous integration, continuous deployment of your applications, and configuration manager to form a modern approach to disaster recovery. In addition, what we see as we apply these DevOps practices is that the concepts of high availability, resilience engineering, and disaster recovery begin to look more and more similar, begin to become one and the same thing. Now, I do want to note that not every application can apply these principles, especially in organizations that have been around for longer terms, especially in organizations that are large. You may very well have some footprint in data centers. You may very well have applications that aren't ready for continuous integration or continuous deployment, or aren't appropriate for stateless configuration. But even in these cases, the cloud can help reduce your costs for disaster recovery, because what you can do is replicate your data to the cloud, maintain a small or no application footprint, so that if you do have a disaster which impacts your data center, you can then relaunch your application in the cloud. And if you do need to maintain a small application footprint, that can be spun up as the demand switches from your primary data center to the cloud. The last thing I want to say here is you need to continue to test, right? If you are new to this, you will likely start by manually testing. You want to make sure you're doing it once, twice a year. You want to make sure more than anything that you're doing it on a regular basis. In DevOps, we also talk about continuous testing. And the next step is to look to increase that frequency of the testing and see if you can actually align it with some of your deployment schedules. If you're doing things like blue-green deployment, you can make it so that you are essentially testing your disaster recovery schedule on every deployment, which is a hugely powerful thing and allows you to ensure your disaster recovery on a continual basis in an automated fashion. So I know I've given you a lot here. I do want to give you some concrete next steps. In order to develop a disaster recovery plan, you want to first start by building your business strategy, implement your disaster recovery, and then test. The strategy starts with looking at your application landscape and determining the business priority of your applications, and then determining what your RPO and RTOs you want to target for your different applications. Based on that, you can develop disaster recovery architecture options, and then you begin to make real risk-benefit analysis where you can compare the cost to the desired RPOs and RTOs. And by combining all these, you can build your strategy for disaster recovery. Then you need to implement it. And the thing I will comment here is, in general, again, for mid to large size companies, it is not a one size fits all. You will need to implement separate DR strategies for each of your applications or sets of services to meet your different RPOs and RPOs based on the application and customer needs. Finally, you want to make sure you're testing. Develop when you're doing this the first time through, you're taking a manual approach. You're going to develop your testing plans. Once you've done that, you want to walk through tabletop exercises, ensuring you're involving all stakeholders and everybody who's needed to help execute the plan. Then, if you can, execute partial testing for systems that need it. And finally, execute full interruption testing. Disaster recovery is not something that is done once and then done for good. You need to continue to refine it, continue to improve it, and continue to test it. But what I can tell you is that if you implement modern DevOps architectures, you can reduce costs and begin bridging the gap between resilience and recovery. I thank you very much for your time. I encourage you to connect with me at LinkedIn, Sean D. Mack, and continue the discussion on Twitter at Sean D. Mack NYC. I'll now hand it off to Chris to talk a little bit about disaster recovery from the AWS perspective.
All right, thank you, Sean. Okay. Sorry, 1 second, getting the slides here. Okay, hey everyone, I'm Chris Chapman. I'm a partner solution architect with AWS Marketplace. And I was a software developer and architect for many years, and now I help customers of AWS automate and template their AWS environments to really master the cloud with scale. And that includes governance and security, and especially reliability. I really want to thank Sean for such a great lead into what I'm about to talk to you about here, especially when he was talking about these overlapping patterns and infrastructure as code, because that's really where I spend a lot of my days working with customers, is on this infrastructure as code and automation. And this is so important in a lot of areas because a company or an organization might have a really good reason for investing in a cloud strategy. And when they implement something like these DevOps practices and infrastructure as code, they find that it gets them all these other benefits as well. And you could almost call those these free benefits or side effects that they get along the way, simply for going down that journey and evolving their practice over time. But today we want to really focus on these the backups and recoveries, or more generally speaking, it's just the reliability. And again, like many things in the modern IT world, when you architect for the one, you're probably also gaining benefits in another area. But I also want you to stop and think about what types of disasters you can run into. Now, some of you may have found, if you've had experience with this, if you've got an instant replicating system, instant redundancy is really good for recovering from a hardware failure, but it's very bad for recovering from corrupted data. So speaking of corruption, we can come up with all kinds of ways that data can become bad. And one of the biggest these days is ransomware, which is just that encrypting your files so you can't use them. but many times the failure or the corruption can simply be user error, deleting the wrong file or overwriting a file with bad changes. So it's important that when you do these types of analyses, you really try to cover all types of failures, redundancy for hardware or technical failures, and then additionally, you need snapshots and disconnected incremental backups for those data corruption failures. Now at AWS, we have the shared responsibility model. So we have built in a lot of that redundancy into the hardware and the backbone of what you're using. And then we provide you that reliability so that our customers can in turn decide to add more redundancy in areas that they think best fits their usage pattern. So maybe this is in the form of that cross-regional failover. Or instead, customers may choose to focus on the non-hardware failures that are really just specific to their usage. So now looking specifically at file backups, this is where AWS S3 has a major impact on your backup solution. With auto tiering and versioning, you can easily set up backups on a schedule which fits best with your desired windows of data loss and recovery. But this tiering system not only helps you with that data protection plan, it also factors into your cost efficiency. So again, like everything we're going to cover today, it's important that you actively monitor and you see what's going on there so that you have the data so you can understand these usage patterns and make decisions off of that. With AWS and reliability, we often think of what I'll call recovery-oriented computing for our customers. And Sean was talking about this a bit, but really this means to focus on your applications. You should be working to abstract your applications from the data. Statelessness is one of those things, and you should be doing that. And you should take the time also to work on these microservices. What you want to get to is fail smaller, faster, and then you can recover in segments. And this type of design and deployment really means that in a failure scenario, you can have better isolation, you have more redundancy, and you have the ability to roll back independent parts. And that just gives you that more modular design, which may also help you with just your development practices in general. So I want to call out one more thing that Sean mentioned, and that's the testing. In the cloud, you only pay for what you use. So we're no longer in a world where disaster recovery means building an entirely new data center. So use that cost model to your advantage and automate and test as often as you can. Now, providing reliability is critical not only to AWS and Amazon in general, but also to our customers. And this is one of the reasons why we formalized and published the well-architected framework. If you're not aware of the well-architected framework, it's a set of pillars, design principles, and important questions to ask as you continuously improve your organization's cloud architecture and really just go down that cloud journey. Within the well-architected framework documents, you'll find some mappings to various tools in AWS for handling the design and the implementations that we discuss in these webinars. But you'll also notice that the well-architected framework is a theory-based guide, which doesn't really dictate, but it's guiding you. It's giving you the framework and the questions to ask as you go through that. Now, obviously today, the pillar that we would want to talk about is reliability. And I think of all of the pillar white papers that's out there, this is the one that is the most dense and full of the most practical and pointed advice with very specific scenarios on how you might implement some of these things. So you really should go out there and check out the well-architected framework in general, especially if you're doing your certifications. But the reliability pillar, when we're talking about backup and reliability, it gives you a lot of equations and ways to add up how to meet certain service level agreements and what those levels of reliability, how they translate into something, and then what you can do on top of that with your applications to increase that type of reliability. But just some quick point outs from the reliability framework. And a lot of this might sound redundant, but it's worth mentioning again, because the first one being we want to automatically recover from failure. And you're going to see a theme in all this. Templating and automation is really the backbone to all of this. So if you're templating and automating, then your automated recovery is a lot easier. If you're building scalable load balanced applications, guess what? That automatic recovery from failure is also included in there, which is really nice. Again, the reliability pillar is going to call out you need to test your procedures. In an on-premise environment, testing is often conducted to prove that the workload works in a particular scenario, but it's not typically used to validate recovery strategies. In the cloud, you really can test how your workload fails, and then you can validate your recovery procedures. So you should do that. You should take advantage of that ability. And then some other things real quick here are just the ability to scale horizontally and increase that aggregate workload availability. That's another important thing because failures are not always surrounding data loss. It can simply be, it can be loss of compute, or it can be overload of compute that bogs the system down. So all of these are different failure scenarios that you should take into account. And then I said it earlier, but stop guessing the capacity. You need to be logging and monitoring so that you know what some of these usage patterns look like. And you'll notice that with a lot of our web, our partner software providers that we're going to talk about later, they have things built in that really analyze the using AI and ML. They're analyzing those usage patterns for you and then extracting that information so that you can get those anomaly errors very quickly. So that's a common theme that you're going to see throughout today. So back to how AWS runs this. With the AWS control plane, it typically provides the ability to manage those resources within the entire region, and this would be multiple availability zones. Now, certain control planes, such as like EC2 or EBS, they have the ability to filter down to that single availability zone. And when this is done, the request is processed only in those specific availability zones, but it reduces the exposure to disruption in other availability zones. Now, there's also in AWS, there's this idea of a regional AWS service, and that internally uses multiple availability zones in an active-active configuration to achieve the availability design goals that we've established. So you see things like that in our identity and access management. Even the Route 53, for example, is across all regions. So different AWS services have different levels of regional support and regional reliability. And that's built in there so that you can make decisions according to how you need your business to run. But looking at this design that I've got on the screen here, it looks great from availability perspective. But I want to go back to what other disasters can we see here? What about corruption, for example? What if someone managed to exploit your API and do one of those SQL injection attacks? That used to be a big thing a few years ago. Maybe they got that drop all command on the database here. Or what if it wasn't a hacker? What if one of your devs accidentally runs their database cleanup script and they left the production connection string in the configuration file? Both of those scenarios would happen, would have the same result, right? And I'm sure that using that highly available instant replication, it would quickly and efficiently move that call across all the replicas. So again, this is why it's important to not only have that reliability in your architecture, but have all forms of your reliability and backup and recovery built into your disaster recovery. So here we would also want to have snapshots and incremental backups on the database. And you should not assume ever that one type of redundancy will prevent all of your disasters. And like Sean was talking about earlier, that recovery time and the recovery window numbers, they're very important, and you really should consider both against the risk that your company can accept. Sean covered that pretty well, so I'm not going to get into it more than to say that cost is usually a big factor in what you do here. So as you move to the right on this particular chart, your cost is going to increase. And I also want to point out that really with AWS partners and the technology you have at your disposal now, it's no longer, backup and recovery is no longer a technical problem. It really is just a business decision of how much risk can you tolerate versus how much cost can you incur to mitigate that risk. And then finally, I want to talk about, because we're talking about different regions here, geographic diversity is very important to many SLAs. And if you're trying to get that next big customer to use your software, they may want to be sure that you can meet their SLAs of reliability. And this is an important factor that might be easily overlooked, right? Your SLA might not be dictated by you. It might not even be dictated by your customer, but by the customers of your customers. So that's an important thing to think when you're architecting things of, who are you targeting and what will their demands be on your infrastructure. Now, if you're following infrastructure as code, you're automating, you're going down those DevOps practices, you're already on your way to this cross or multi-region capability. And we'll also cover some partners today who can help you get those data and backups in position for that cross-region failover or just cross-region consistency. Even account resilience, which is another thing to think about. So Sean talked about these strategies, and I just wanted to put some time windows on what some of this might look like. So if you're going to follow a backup and restore, you've got the data there. Maybe you've got the compute is templated and it's ready to go. It's just not running, right? So here we're looking at a RTO maybe in the 24-hour, the 1-day range, right? There's going to be a lot of manual intervention, but you have all the data, you can bring it up. And then there's the next step would be the pilot light. So now we're into minutes or hours maybe. You're maintaining a minimal version so you can have that seamless failover, but maybe not with full capacity. And then finally, there's the warm and the active. And this is where things are running. They're running and they're waiting, right, on the warm standby. So they're not really processing stuff, but they're waiting to go into immediate action. And then on the active, again, that's the same thing. We've got our compute and everything is running, and it's but instead of waiting for doing it, it's actively processing requests. So that's where your load balancing, your DNS strategies, all of those come together to give you that full active cross-region availability. And then additionally, if you're doing that properly, you can also route requests and you can start doing other things like finding out where your customers are coming from and giving them the least latency possible to the compute resources they need. And then more recently here, we've had the data residency requirements like GDPR and stuff like that. So a lot of people are finding they need to be running multi-region because the data itself has to stay in a specific area. So these are all things to consider, and they may or may not be directly related to your recovery. And speaking of numbers, I always like to see this comparison here, and this is right out of our reliability paper. But it's really useful to look at these numbers and then see what that means for a given year. And this is important when you're looking at that risk and you're saying, okay, how much does 5 minutes of downtime or an hour of downtime, what does that mean as cost on my company? And that's helping you build that budget and decide how much of that compute, how much left or right on that previous chart do you want to be? Do you need the full active, or can you handle a few minutes of downtime? But again, that's based off of that reliability. And then you'll also, the AWS services out there, all of these SLAs are public knowledge, and you can go and look up any given service and see what the stated reliability and resilience is on any service. So at this point, I want to talk about, we've talked a lot about what AWS can do, but one of the biggest advantages with the cloud is not just the cloud provider, but all of the third-party ecosystems and the partners that AWS has gathered over time. We have some fantastic partners, and they're really driving the expertise and the ability in areas that, whereas AWS, we provide you the building blocks to do things, our partners are taking those and really turning them into full solutions that are turnkey for their end users. And one of the best out there is N2WS. They really are a cloud-first organization, and they've been delivering world-class results, including dramatically reducing these RTO windows, which many companies can now measure in minutes and seconds with N2WS. Additionally, N2WS, they work through tags, so it's a very small integration requirement. It works right alongside your infrastructure, And it creates those native snapshots, which means you could even use another program in AWS to restore. So you're never really locked into WS. Additionally, they help you minimize your storage spend by deleting these EBS snapshots so they'll copy them to S3 for this long-term retention, and then they'll get rid of the snapshots. If anybody's ever had to go in and automate that, it can be, there's a bit of a learning curve there, and Into.ws can help you do that right out of the box. Additionally, they can help you, back to this testing here, they can really help you schedule regular dry runs to improve the disaster readiness, improve the compliance towards those SLAs or those auditors who are checking them, right? And then finally, Into.ws, they're not really just a backup and recovery partner, but they also have other features built in, such as cost optimization with resource control. And that allows customers to go in and turn off non-critical EC2 or RDS instances, for example. You can do that on demand or on a schedule. And that really helps you just lower your compute cost and eliminate cloud waste. So I want to talk about a couple customer success stories with Into.ws here. The first of which is Essilor Group, which is a world leader in ophthalmic options. With 74,000 employees and centers around the world, they distribute in more than 100 countries, and they have a responsibility to over 350,000 eye care professionals who really expect their systems to be available 24/7. So we're looking cross-region availability here, lots of people, lots of different areas. And so rapid recovery was obviously a big concern of theirs. Essilor's large AWS environment had a lot of complex policy needs. Their global deployment included 3 geographies in the Americas, Europe, and Asia, and more than 20 AWS accounts in 1,500 EC2 instances across 30 different VPCs. Additionally, Essilor used different policies to back up production and non-production workloads, and they use different policies for each type of workload. So they've got a lot of different SLAs, they've got a lot of different backup and recovery plans they need to put into practice. Now, prior to using Into.ws, Essilor had an in-house solution with custom scripts to manage all their backup and recovery of their AWS workloads. Now, this was done with cron-based tool with EC2 instance tags, and this manual approach had a lot of challenges for their IT team. It was taking a lot of time to do the recovery. So Essilor turned to Into.ws because it allowed for not only this easy onboarding of other Essilor regions, but they could also scale their AWS deployment alongside Into.ws. Its enterprise-grade backup and disaster recovery uses that native snapshot technology in AWS to provide a complete disaster recovery solution. Now, after implementing Into.ws, Essilor executed a cross-region recovery drill utilizing hundreds of EC2 instances in many of their AWS services. And this really helped them validate the process and restore the full environment. It only took them 2 hours to do that instead of 2 days with zero learning curve on there. So that's a really fantastic story about someone who could leverage a partner and get very rapidly to where they wanted to be on their recovery time windows. Additionally, with Into.ws is Git. Now, Git is an app that lets people hail a taxi from their smartphone. The service is available in more than 120 cities in Israel, UK, Russia, and the US. The company was founded in Israel in 2010, and the organization is currently a $1.4 billion organization and employs about 1,000 people around the world. Steady growth has resulted in a number of AWS accounts for different parts of the business and around 60 EC2 instances running workloads including SAP, Microsoft Active Directory, and business intelligence applications. It also has about 20 RDS instances. So Git's main challenge is complexity, which definitely affected their backup procedures. Git used AWS Lambda functions to trigger backups of its Amazon EC2 and RDS instances, but it found it difficult to track snapshots, which snapshots belong to which users and which version each snapshot corresponded to. So, it was a big jumbled mess. And as a result, they were archiving just terabytes of old data because they didn't know what was safe to delete. And then on top of it all, they had to manually go in there and maintain the tags on the instances, and they were constantly looking for new instances that people had not tagged appropriately, right? So they turned to N2WS because of its ability to restore these workloads in seconds. And now, instead of spending hours searching for the right snapshot that contains that file, their IT team can have the file available to end users almost immediately. They really appreciated the easy account integration that N2WS provided. And when Git started with N2WS, it was backing up around 50 instances, and now it backs up its RDS volumes additionally. So they implemented the resource control, which is what I mentioned earlier, to stop its large EC2 instances at night and on the weekends. And this had an additional savings of around 50%, or $2,000 per instance per month. That's over $60,000 a year to better, they were saving just on that resource control, in addition to doing their better backups and restore strategy. So it feels really it's much better for their IPO when they go for that. Now, another company I really like out there on the marketplace is Rubrik. And when you're asking, what does simplifying backups mean to you? Well, Rubrik's answer to that is to take your business requirements and translate them into SLA policy templates, which you can apply to many different types of entities for the backups. This means they also provide this cross-account centralized policy. And this is not only cross-account for AWS, but it's also hybrid. So it's on-prem and in the cloud. You get that centralized management of VMs and the cloud all in one spot. Additionally, once those SLAs are defined, Rubrik can automatically move your data into the appropriate tiering of storage on S3 to really make sure that not only are your SLAs being met, but your storage costs are also minimized. So they provide this hybrid solution. They can also accelerate your migration. Maybe you're moving compute from on-prem to the cloud. You have to move the data as well. Well, you can archive the data on-prem, and then all those licenses can transfer seamlessly from on-prem to the cloud. So there's no need to worry about licensing while you're doing your migration. And additionally, they can not only provide a multi-region backup, but they can also help you with multi-account backup. So within AWS, can you currently fail over to a completely new account? Well, with Rubrik, they can help you get there. And then finally, they have Radar, which is their ransomware program, which can inspect your data and give you the insights you need concerning windows of loss and that scope of infection. So when your files are getting hit by ransomware, they can be a really big help in figuring out how bad that is and how to begin to mitigate it. And then finally, they provide that file level recovery, so you can do a very surgical restore when necessary. So Par Pacific is a customer of Rubrik, and they own and operate energy and infrastructure business, especially out in Hawaii. They're valued at $3 billion right now, and their holdings are responsible for about 80% of the refinery capability in Hawaii. So protecting their refineries is critical to their success, but they were relying on this on-premise data and archive, and then they were moving that over to S3. They additionally, they had more than 60 AMI instances for cloud production in AWS. Now, Par Pacific found Rubrik through the AWS marketplace, and Rubrik's solution really aligned with their goal of simplifying their backup and recovery strategy. All of their software subscriptions were able to transfer from that on-prem data center to AWS. And then they found that these fast restores with Rubrik's integrated search, which is live mount for VMs and databases, and this file level recovery was really what they needed to get them moving. And with Marketplace, they found they could leverage their favorite vendor and then have all of that billing roll up to their AWS monthly bill, which also helped with their enterprise spend agreement with AWS. Additionally, one of the biggest value drivers for Par Pacific was that Rubrik works with ServiceNow. So they were able to provide self-service recovery and restores through their through their ServiceNow ticketing system. And this was core to that value when they were considering Rubrik in AWS. After implementing Rubrik's solution, Par Pacific was able to recover a critical SQL database in AWS within minutes instead of days that it would have taken previously. So that's an excellent turnaround time, just going from days to minutes on a high value database there. And our last partner from the marketplace I want to tell you about is Actifio. Actifio supports a wide variety of enterprise applications and databases. Whether they're running in virtual machines, the public cloud, or physical servers, Actifio protects and enables instant recovery. Actifio also reduces the backup windows and associated performance impacts by up to 20 times by delivering an application consistent, incremental, forever backup solution. So their ability to store backups in a native format on any storage enables production-like performance post-recovery. And additionally, Actifio can leverage S3 object storage to lower that cost while still offering their instant recovery ability. So if you're looking to modernize your backups and improve your RTO and RPO, along with those retention SLAs, if you're on-premise in a private or a public cloud or hybrid, all while reducing cost, risk, and complexity, you should really go check out Actifio. And this is exactly what Brigham Young University did. They're a private university that focuses on undergraduate research. It maintains 33,000 students across 3 campuses in Utah, and it employs 3,800 different academic and administrative staff, which help maintain their prestigious reputation in both academics and sports. Now, the school wanted a comprehensive disaster recovery capability and cloud-based offsite backup. And because their current platform was built on an outdated code base, it couldn't provide sufficient protection for critical applications. And data and restoration could sometimes take days. So any replacement needed to be simple to operate and enable high-end performance while being straightforward with cloud backup and provide multi-tenancy support. So when it came time to perform a remote DR function, Actifio moved their DR to the cloud with ease. Actifio's simple installation and operation, in combination with that high-speed backup and recovery, the multi-tenancy, and then the responsive customer support, gave everything BYU needed to eliminate its on-site DR location while lowering both hard and soft costs. So they've enabled their users additionally to self-administer, freeing their time for their engineers, and time spent babysitting the system has been reduced from several hours a day to almost none at all. So wrapping up here, all of these partners I mentioned today provide application consistent backups for AWS resources, and each has their own positives depending on what you need in a backup solution. So I really suggest you go out to AWS Marketplace and take a look at all of our partners and try some out and see which works best for your people in your process. AWS Marketplace also really simplifies the deployment. A lot of products on there are available software as a service, so you have nothing to deploy. And we also have a number of standard deployment mechanisms, including AMIs, CloudFormation, APIs, and even container and SageMaker deployment options. And of course, having humans to support you is always important. And that's actually part of what we do, my team, as solutions architects at AWS. So as we wrap up here, I'll give you some final points to consider. Any good reliability plan is based on templating and automation. So take those lessons we learned from software developers and apply them to your infrastructure. You should be checking in templates, running them through a pipeline, and then distributing these standardized, well-architected patterns throughout your organization. Everything is a balance with time and cost. Consider your RTO and your RPO, those windows. Find out ways to implement those SLAs within all aspects of your infrastructure, and then work with stakeholders to evolve the process over time. And finally, leverage the expertise of others, helpful humans with both the expertise and the experience, such as our consulting partners and software sellers. Partners allow you to focus on the fundamentals of your business. Into.ws, for example, has tons of experience helping IT teams deliver data protection. So I really invite you to use the AWS Marketplace like any other resource on AWS. Experiment, try out some different partner offerings, and then make the decision based on your own data and input. So I'd like to thank everybody for your time this afternoon. And I will, at this point, I think we've got a couple minutes, so maybe we'll take a question. I'll turn it over to Erica, and we'll look at some questions on the panel here.
Great, thank you so much. And Chris and Sean, appreciate the time and detail you went through. To first answer everyone's most common question today, yes, this presentation will be made available in a recorded format as it is live right now. And then also we will be sharing a PDF of the slides. So those will come in a more formal email to everyone who has registered for this event today, probably early next week. So again, this will be made available. We'll send you a link to a recording and the slides. So I think there are a few folks who may still be on here. Chris, there are some questions in general that I think have come in that are very specific to someone's environment. So I did want to call out the best way to reach out to the solutions architect team. Chris, perhaps you can provide that email address, but we will send that to everybody, a forum to set up some time with the solutions architect. So someone was asking a pretty interesting question around CI/CD. Chris, if you have a second here. So if you're using CI/CD with Git, what would be an AWS best practice in this regard?
Okay, so I'm going to make some assumptions on that
Yeah.
we're talking about infrastructure as code in this case. What I like to see, and this is common to a lot of DevOps patterns, is first you want to be able to check in your templates, and then you want to be able to validate them. So there's a couple tools out there I like for that. CFN NAG is a open source Stelligent product. It will go through, it gives you whether your YAML or your JSON is valid template. And then you can do something like TaskCat is another great program that was an internal AWS application that we released on open source, and that will actually run the CloudFormation template. So as part of your DevOps process, you want to do that shift left. You want to bring your errors closer and closer to that check-in, right? And that's really what enables you to do that. You need to validate your templates, run some basic security, maybe even spin up the whole template before it gets published out. Now, two things on that. Once you publish your template, especially if you're in AWS, you want to make sure you're in a very locked down S3 bucket. So ideally, only your automation process has access to that bucket, because CloudFormation or Service Catalog has to come out. All those templates must come from S3. So lock down that bucket. That's your known repository of good templates. But then what I would do is back to the Git or the code commit, whatever you're using for your version control. I would open up some branch check-in abilities to your entire organization. I've seen some really good successes with very large companies where they opened that door up and they started getting innovation on cool, unique infrastructure builds from a lot of places throughout their organization. And that really, it takes the load off of your infrastructure team. Instead of them being the only creators of infrastructure templates, they suddenly become the validators, the approvers. They're no longer the bottleneck for creating the content. And that's a really cool place to be at for a company when you really want to grow this infrastructure as code and the innovation around your cloud architecture.
Great, thank you. I think we have time for one more, if we can brief this. Besides resilience, are there some other backup service options that are native to AWS?
Yeah, there's quite a few. So we've got the snapshotting ability, so you can do that incremental snapshot. I would say auto scaling is one form of resilience if you're load balancing. So we handle a lot of that stuff. There's a lot of good templates out on GitHub in AWS samples. We'll get a link to that for you in the email, where natively speaking, say you've got Elastic Beanstalk, you upload your app to that, you have the auto scaling. And because of that, if you have a stateless application, if that goes out and you've set your minimum to 1, you also get auto healing in there. If that application freezes up or that server freezes up, it'll kill it and restart it. So there's a lot of stuff that's just natively built into some of these services that you could consider part of the recovery and resiliency model.
Great. Thank you so much. I believe we are at time now, and I just want to thank everybody who joined us today and took an hour out of your schedule. We realize time is really crucial, and so we appreciate the time you gave us. Again, this has been recorded. We will clean this up a little bit and send it out to everybody who has registered for the event. Thank you, Sean, and thank you, Chris, for the presentations. If you do have any questions, we will post the essay alias in an email as well. I just don't have it on me, but Chris, I think that we can, any specific questions that have come in here where we haven't been able to get to you, we will respond and give you that alias as well so that Chris and his team can help you guys out.
Yep, definitely.
Okay. All right. So thank you, everyone. Apologies we can't get to all the questions, but have a great day and take care. We'll see you on our next event.